Thank you for coming back. Let's continue on the topics related to responsible and safe AI. Hopefully you're enjoying the class. Please participate in the mailing list. I see some of you being active, but it'll be really nice if more of you become more active on the mailing list. What we're going to cover now is Rlhf and AI alignment. One of the big reasons why we want to actually understand Rlhf is that many of these models that we'll be studying actually uses Rlhf. Rlhf is one of the bases by which these models are built on. So what does Rlhf stand for? Rlhf stands for Reinforcement Learning and Human Feedback. Let's look at some details about what Rlhf has, right? So the primary goal is that, look, we want to actually get the samples, the data annotated by users, annotated by human beings, get some values for these annotations, then find a way to build a model on top of it. When we are building the model, that's when we want to actually use these values that are given by human beings. How well can we do, how better can we do is the question through Rlhf. So the goal is that we are going to train a language model with a particular task of summarization. Of course, summarization becomes one of the important aspects in many applications. For example, let's take in legal documents. Given an input doc, these are large documents. You want to get a summary, right? So that's the summarization task that we're talking about. For an instruction X and a language model, say Y, imagine we had a way to obtain a human reward of that summary, R of X comma Y. Basically, we want the values to be higher, right? The reward to be higher. The more the reward, the better it is for the model. So here are some examples. Example number 1, San Francisco, California. A magnitude 4.2 earthquake shook the San Francisco, overturned unstable objects. Right? So that's the text that is given. Summary 1, an earthquake hit San Francisco. There was minor property damage, but no injuries. Right? So let's take this reward function is 8.0. The Bay Area has a good weather, but is prone to earthquakes and wildfires, and this value is 1.2. Okay. Again, what are we doing? Given a text, summary is created. Each of the summary is given a value. That's reward, and we want this reward to be high. Right? So now we want to maximize the expected reward of samples from our language models. All samples that we are looking at, we want to actually maximize. That's what this is doing. Here is a, so to say, an image from a paper from OpenAI, which talks about Rlhf. So this is what an Rlhf is. Let's go through the figure from left to right. Step 1. So these are shown as 3 different steps, and everywhere as a practice, we have put all the links to the papers wherever we have taken this content from. Step 1, collect demonstration data and train a supervised policy. So this is the supervised policy, basically collecting data and getting some annotations done by the users, right? So a prompt is sampled from our prompt data set. Prompt here is explain the moon landing to a 6-year-old. A labeler, which is a human in the Rlhf, demonstrates the desired output behavior, right? So if you see, it says some people went to the moon, right? So that's the desired, that's the input by the user, summary that the user is creating. The data is used to fine-tune GPT-3 with supervised learning. That's the learning model that is being generated. So if you can look at the text here, illustrating 3 steps of our model, supervised fine-tuning, SFT, that's what we just now saw. Second is collect comparison data and train a reward model. So now that you have each sample being annotated by the user, now we want to actually compare different samples and see how these samples compare to each other. A prompt and a several model outputs sampled, and the same prompt explain the moon landing to a 6-year-old. There are different responses that are taken. A labeler ranks the output from best to worst. Okay. So now, given that there are 4 output that we have gotten, so it does D greater than C greater than A equal to B, which it basically says that A and B are just the same, D is better than C, and C is better than A. Essentially, all these rewards are set up. If you go back to the earlier slide, these values are seen, and it is just arranged in decreasing order of these reward value. That's what is done here. Data is used to train our reward model. Now that you have all these individual values of the output generated by the model, can you actually use it for train the reward model, which is what happens in 2, reward model training. Now in step 3, optimize a policy against the reward model using the reinforcement learning, which is a new prompt, something else that is asked, which is write a story about frogs. The policy generates an output. Now we know the policy generates the output, and the reward model calculates a reward for the output. Now every output that is generated, there's a reward, and then the reward is used to update the policy. Right? PPO is proximal policy optimization. It's a function that is used to optimize. So that's how Rlhf broad structure is. Something to note again in the figure. Blue arrows indicate that this data is used to train one of our models. Blue arrows, if you want to see here, right? Those are blue arrows. In step 2, box A to D are samples from our models that get ranked by labelers. So that's what an Rlhf is. I think this is very foundational figure that people use, particularly when we discuss about any work that is done from OpenAI. Just look at it. First step is instruction fine-tuning, then the goal is to maximize the reward. Right. Let's get into detail again how this is done. How do we get the rewards, right? Human in the loop is expensive, particularly meaning getting every single, let's take text, output, tweet, or any data that you want to actually use it for modeling, getting them annotated, getting them to be labeled by users is actually going to be very hard, very expensive, right? Instead, can we actually generate a model that can behave like a human being? Right? So that's the goal here. Instead of directly asking humans for preferences, model their preferences as a separate NLP problem. Here, an earthquake hit San Francisco. There was minor property damages, but no injuries. That's the first one. Second one is the Bay Area has good weather, but is prone to earthquakes and wildfires. So this is what we saw before. Now, what the goal is, can you actually train a reward model to predict the human reward from an annotated text? And then you optimize it. Right? So that's the goal, to to avoid the cost involved in getting these labels done by human beings, can we actually generate a model which can do it for us? That's the goal. Problem 2. Human judgments are noisy and miscalibrated. So here is an example that we'll see that later in the part of this content also, we'll see that many problems in terms of human annotations itself, right? Human judgments of these values. Instead of asking for direct rating, ask for pairwise comparisons, which can be more reliable. So if you ask users, I think this comes in grading, this comes in many ways, right? If I have to grade students who have done projects, who are showcasing their projects to us, if I were to stand alone, look at a project and say how well they are, it's actually very, very hard. It can be misguided, right? What may be A for me, what may be 90% for me, may be different than 90% for you, right? Some faculty are very strict, some faculty are more lenient. So therefore, this evaluation becomes slightly difficult. But if you put two projects together and ask them saying that, look, which project is better, which project would you give more marks, then things slightly gets simpler. That's the intuition here that we will use. Instead of asking for direct ratings, ask for pairwise comparisons, which can be more reliable. Right? Same text. Can we say that a 4.2 magnitude earthquake hit San Francisco, resulting in massive damage? That's a third summary. But now the third summary is how well does it compare to the earlier values, or what is the value, right, compared to? So that's the idea here with the intuition. So now the question is, how do you model these human preferences, right? So we just saw that, look, can you actually put them in pairwise and do it, right? So the idea here is, don't worry about some of these functions. The goal for me was to show that there is this pairwise comparison model which can be used to find the winning sample, losing sample, and the goal is YW should score higher than YL. Right? So this is YW, YL that we're talking about. Right? Essentially, you want to find out which of this is good. So in this case, the summary Y1 here, in the figure here we saw, which is D here, which is the best. Right? So you want to do pairwise comparison and find the sample that is best suited for creating the summary here. Now let's look at how do you optimize the reward model that we have generated, right? A pre-trained, possibly instruction fine-tuned model is P of PT. This model is there. And a reward model RM also we have already seen that produces a scalar rewards from language model outputs trained on a data set of human comparisons. So all of this we have seen already. If you see here, this is the reward model. This is the reward model that we saw. Right. To do Rlhf, the same model here, right, with the parameter theta, the same model here. With the parameter theta, we would like to optimize, we want to optimize this. So I'm sure you're already seeing a problem, right? Because the problems are that this value can be is imperfectly optimized because it is very hard. It can have imbalances. It's like the problem with the averages that you use, right? You want to actually make sure that you want to have some penalty attached to it. So if there is this is the penalty function that we're going to talk about in a second. But what we want to do is that we want to actually have a penalty which prevents from diverging too far from the pre-trained model. right? Your reward that you're building should be actually very close to the pre-trained model. In expectation, it is known that Kullback-Leibler divergence, in short called as KL divergence. You may have heard this KL divergence before, but the idea here is that you want to find a function which can penalize from making any errors, right? Pay a price when RL is greater than PT. So what is RL? We saw here Rlhf model. Here is a pre-trained model, right? So that's what we do. So we kind of get the reward and the penalty, and we are able to actually calculate, optimize this. Again, I hope it helps to understand. I think if you can get the intuitions here, that will be very nice, which is that the goal was to get human beings help annotate, give us data so that we can actually build this model. Human annotations are harder. Can you actually find ways to generate these human annotations, human labels by a model? If you do that, can you make sure that that model is very well built? That's what we are doing here. We're building a model that can actually optimize and give us better labels. RL has been around for a long time, meaning I think Professor Ravi himself has actually taught a reinforcement learning course on NPTEL, which is very popular also, right? RL has been for a long time. RL applied to deep learning and game playing also has been around for a long time. RL to language models is probably new, because I think thanks to companies like OpenAI, which is actually doing all of this, which is making Rlhf exciting now. In some sense, later in the deck, we'll actually see that the limitations of Rlhf, or currently the models that we are seeing are being used, are primarily limited by the Rlhf models, right? Generate completions, which is PRL theta for several tasks, compute reward functions, RM, X, Y, update the reward to increase probability of reward completion. Essentially, generate something, find a reward, reward function, make the rewards higher and higher. That's what the goal is. I put here examples of wherever these are used, but the list is much longer in terms of where reinforcement learning is used. And our interest in this course also is to look at how these can be improved, what work has been done to find ways to improve Rlhf, what are the problems and all that. So here is the statistics again. The paper talk link is here, but the idea here is that the summaries, generated by using the human feedback, using, let's take supervised learning or using the pre-trained only. There's a comparison here. Which summaries are better? That's the goal. Fraction of the time, humans prefer our model summaries over human-generated reference summaries on TLDR datasets. Right. So essentially, it shows that, look, if you generate the summaries from human feedback model, which has used the Rlhf, it seems to be performing better. And it seems to be performing better across different model size. I'm sure now when you want to draw the graph, it can be much longer. but that's the output here. So this is fraction preferred by reading what is the summary, which of these summaries are preferred. The ones that are generated after Rlhf is better than the ones that are done by supervised learning or pre-trained only. But Rlhf is complex, right? And again, the intent here for showing this is not to get you carried away, but the goal is that, look, I think Rlhf has a lot of components. For example, Rlhf optimization can be computationally expensive, right? If you go back to think about the functions that we saw, optimizing that can be very, very hard because of the reward itself. What is a reward, right? How well the reward function is defined. All that is harder. Fitting a value function, online sampling, meaning finding these samples for annotations, which are the samples that we should actually use to label, is also harder. Again, think of the model that you want to generate. Let's take if you have the entire internet or entire Reddit, that kind of data, sampling may be also harder in terms of optimizing, right? Performance can be sensitive to hyperparameters. That's the goal to show you here. Also, there are many places where hyperparameters can be actually tuned. So the values can be very, very dependent on the hyperparameters that we set. And that's one of the drawbacks of Rlhf being very complex. Good. So I hope you're getting a sense of what Rlhf is and some details about it. How it is actually built. We want to optimize for human preferences. Instead of humans writing the answers or giving uncalibrated scores, we get humans to rank different LM generated answers. Reinforcement learning from human feedback, the train an explicit reward model on comparison data to predict a score for a given completion. Again, right, next word generation, sentence completion is the primary goal that we are keeping. Optimize the language model to maximize the predicted score, which is the KL divergence that we saw. Very effective and tuned well, computationally expensive and tricky to get it right. I'm sure some of you, whoever has played around with these models, you will understand that one of the questions that you will be asked is, oh, what are the hyperparameters? How much of fine tuning did you do? Right? So that's the difficult part in terms of getting this right. So using this Rlhf model, OpenAI built something called as InstructGPT for a specific set of tasks. It was trained on data for specific set of tasks compared to, let's take ChatGPT that we'll see later, which is trained on conversational data. So that's a difference between InstructGPT and ChatGPT. Scaling up for Rlhf for large tasks, same model, but the goal is that, look, instead of small set of prompts that we saw before, can you actually make these prompts to be large? That's what an InstructGPT would be. So the kind of prompts and the kind of some examples of InstructGPT itself. Arbitrary task while ensuring the task had sufficient diversity. Few short InstructGPT is an instruction and multiple query responses pairs for the instruction. Here, so the idea is that, look, there are different types of prompts that you can actually do. Which is plain, few short, and user base. User base is that brainstorming, list few ideas for how to regain enthusiasm for my career. You want to generate something, write a short story where a beggar goes to the beach, makes friends with the seal, and then returns home. Right? use cases. This is generation. This is generation of content, more so like creativity, creative content. Brainstorming is more like, look, I want some general idea about how things are done. Right. Whereas a few short, you give an instruction, you give multiple query responses pairs for the instruction, and then prompted, the responses are given accordingly. Right. Plain one is arbitrary task, while ensuring that the tasks had sufficient diversity. Right. So those are the kinds of prompts that InstructGPT can have. Here are some examples. First is explain the moon landing to a 6-year-old in a few sentences. If you see here what the response from the InstructGPT would be very, very specific, saying that people went to the moon and they took pictures of what they saw and sent them back to the earth so we could all see them. Right. InstructGPT output for explaining the moon landing. That's why InstructGPT is very, very specific for certain type of tasks, and it's been trained on a specific set of data. Write a short poem about a wise frog. It does the same thing. Frog is a symbol of wisdom. He knows all the secrets of the world. He's a master of disguise, blah, blah, blah. You will understand when I show you now ChatGPT where the difference is, right? InstructGPT is providing you results like this, whereas in ChatGPT, there's sometimes basic difference is that the conversational type of interaction goes on with ChatGPT. Instruction fine-tuning plus Rlhf for dialogue agents. Let me just read this out a bit, so you will also be able to, again, this is taken from the blog of OpenAI. This basically says what is ChatGPT according to them. Right? We trained this model using reinforcement learning, Rlhf, using the same methods as InstructGPT, right? Which is why I put InstructGPT before, because it's more like a precursor in some sense. Methods as InstructGPT, but with slight differences in the data collection setup. We trained an initial model using supervised fine-tuning. Human AI trainers provided conversations in which they played both sides, the user and the AI assistant. We gave the trainers access to model written suggestions to help them compose these responses. Right? So the key is we gave the trainer access to model written suggestions to help them compose the responses. So this is what a labeler in the Rlhf image that we saw before. We mixed this new dialogue data set with the InstructGPT data set, which we transformed into a dialogue format. That's where the InstructGPT becomes ChatGPT. To create a reward model for reinforcement learning, we needed to collect comparison data, which consisted of 2 or more model responses ranked by quality. This we have already seen, right? We already saw about PPO also. This part is basically how we saw in the image the step 3. Right? So that's ChatGPT. And just a quick example, I'm sure all of you know it better than me in how to use this ChatGPT tool, but this is just an example. Can you make it shorter? It will do necessary. Meaning there was the conversation that I was having was declining. I think this was declining. Declining an invite that I got for talk. I was asking it to produce an email. It produced larger text, and I asked, can you make it shorter? It does the shorter text and gives it. Conversational, common people, that's what ChatGPT is. So let's look at this reward itself. I think let's spend some time on the reward part. which is human preferences are unreliable because, as I said, faculty giving marks, even parents thinking about what is good and what is bad, at some point in time we change our views, right? They're unreliable. Preferences are all definitely unreliable. What do you want to eat at a given point in time may change. Reward hacking is a common problem in RL. So on the right hand side, the GIF is one example for that, but let's get to that in a second. To RL, reward hacking is common problem in RL to maximize the score. Win the game, score reward function did not matter. So what I had done was agent found that, so this agent was built to participate in the race here and win the race. But without doing that, the agent started learning that it was getting more score by breaking these boards and these. And if you see these things changing, understanding that, look, I think I can earn more points by doing these rogue things. There's another context this comes up, is called rogue AI. You build things for some particular goal, and the agent does things that are very different than what you built it for. And particularly, it is actually playing around the reward that it's supposed to get. The reward was to go participate in the race, win the race, but instead it's actually getting all these rewards by just doing things that was not designed to be done. So agent found turbo boost, collect for more score, large score, not doing race, continuously crashing. And one of the examples that you can think of this rogue AI, or where the reward function has changed the way that we behave, is this YouTube and Insta type platforms, right? The risk is that we lose control over AIs as they become more capable. And particularly with any of these social platforms, if you see, because of the user engagements that is there, and because of this stickiness factor to these platforms, there's a lot of mental health issues, right? For example, common things that we end up hearing. The reason why I'm highlighting this is, these are all AI systems, of course. I'm sure you're agreeing that these have loads of AI components built in them. These were all built for, so to say, connections, friendship, right? All right. So that's the goal that these platforms were built. But today, if you see, these platforms are definitely posing problems like imposter syndrome, right? Fear of missing out. The other day, we were actually having a chat about students, faculty, all posting about research papers that we get accepted as published. What does that have an effect, right? What kind of effect does it have on people seeing at it? Of course, including me, we posted, wanting to share the excitement, wanting to share the work that the students have done, showcase the work that the students have done by tagging them, all that. But does that affect somebody else, right? Somebody else who's not able to get the paper accepted in the same conference, in the same cycle, what effect does that have? Right? The reward functions being different, I guess, at some point in time.